Alright, so today we'll be talking about limits at infinity. And limits at infinity are just basically what happens if I have an equation that approaches infinity. What we're doing is we're talking about going to the left or to the right. So, let's go. Alright, so the basic thing that we're just talking about is just what happens when x goes to the right and what happens when x goes to the left to infinity and negative infinity. Okay? Alright, so there's two directions that we're going to be going with this. Alright, so what the first thing we're going to look at here is the limit as x approaches infinity of c divided by x to the r power. Okay, that's just going to be 0. So in other words, the bottom of the fraction is raised to a power of r. As that number x gets bigger, okay, no matter what power it is, if it's well, as long as it's a positive rational, so this could be 1, this could be 3,000, it could be 3 halves, whatever. The limit will actually just approach 0 as x approaches infinity. Okay, now also the same thing works is if we're going to negative infinity and it turns out that x is less than 0. So the same will actually work out for this way. Okay. Alright, so the major thing is that you want to be able to take your actual function and break it up into a whole bunch of these, because if you can find these, you can turn them into zeros and just work with it that way. So like for example, now obviously if we're going the other direction and we're finding out, you know, let me see, limit as x approaches infinity. Okay, let's say we had 2x to the 4th minus x squared minus 8x. Okay, now if you notice, I have no such thing in here. However, I have no variable. I have no fractions in, sorry, not fractions, but I have no negative exponents in here. And so this one you would just assume is going to be infinity plus infinity. Well, it's actually infinity minus infinity minus infinity. And some of you guys are thinking, oh, that's going to turn into 0, but that won't, because there's different sizes of infinity, so you cannot include this. So what we're going to do is we're going to factor out an x to the 4th. Now some of you guys are going, wait, I can't factor out an x to the 4th. Yes, you can, because remember, division is just subtraction, so you got 2 minus 1 over x squared minus 8 over x to the 3rd. Okay, now for those of you guys paying attention at home, this is still a limit. So this is the limit as x approaches infinity. Okay, this number on the outside, that will be infinity, which makes sense. Okay, so that number is infinity right there. That x to the 4th approaches infinity, whereas the other numbers approach 2 minus 0 minus 0. Okay, which infinity times 2 is just infinity. So this does approach infinity, but not the normal way we're used to. Okay, so what you're going to do is, the major thing that you want to identify is the largest exponent variable, and just factor it out, just so you get a whole bunch of these bad boys, just to be able to turn those into zeros. And that's the most important thing right there. Okay. Alright, so let's take a look at another one. Let's go to, let's say the limit as x approaches negative infinity and 1/3 t to the 5th plus 2t to the 3rd minus t squared plus 8. Okay, so what we're going to do is notice, okay, the biggest is t to the 5th, so I'm going to factor that out. So I'm going to have in front t to the 5th, parentheses, 1/3, plus 2 divided by t squared minus 1 over t to the 3rd plus 8 divided by t to the 5th. Okay, now that's going to turn into infinity, which is the approaching mark of that. Well, it's actually negative infinity. What am I doing? Negative infinity times 1/3 plus 0 minus 0 plus 0. Which, of course, we don't need to mess with anymore because that approaches negative infinity. So that works right there. Okay? Alright, now let's take a look at some specific ones that are a little bit tougher. Like, for example, this one right here. Let's go. Okay, the limit as x approaches infinity, and let's say we're working with parentheses. No, let's just go 2x to the 4th minus x squared plus 8x, okay, all over negative 5x to the 4th plus 7. Okay, so I'm going to do the same matter of fact, except I'm going to notice that the largest exponent variable is going to be x to the 4th, and I see it in 2 spots. So when I factor it out, I'm going to have x to the 4th on the top. So x to the 4th on the top, and I'm going to have 2 minus 1 over x squared plus 8 over x to the 3rd divided by x to the 4th, parentheses, and I'm factoring out at the bottom. I got negative 5 plus 7 divided by x to the 4th. Okay. Alright, now if you notice I have an x to the 4th on top and an x to the 4th on bottom, so that leaves nothing. And then if I find the limit as x approaches infinity, this turns into 0, this turns into 0, and this turns into 0, leaving me with negative 2 minus 0 plus 0 on top divided by negative 5 plus 0. And that just turns into, well, that's not negative 2, that should be positive 2 up top. This all turns into negative 2/5. So it makes your job a whole lot easier when you actually divide it out and everything, okay? And the same thing works for when you have square roots. You just want to square root it. Now, however, I do want to recommend this one course of action. So let's bring that back up. Okay, if you're doing the limit as x approaches, oops, as x approaches infinity, let's say you had the square root. Square root of 3x squared plus 6 divided by parentheses 5 minus 2x. Okay, something like this. Okay, so what we do is we bring it out into everything, and so what we're going to do is factor out an x squared out of top and bottom because that's the largest. So it's going to be square root of x squared times 3 plus 6 divided by x squared, okay, divided by x squared Well, in actuality, on the bottom, we're probably just going to divide out an x because that will make our job a lot easier, because if you notice, we're going to be square rooting an x squared. So that's going to be kind of nice. 5 minus 2x. And plus, if we factored out, divided by x. There we go. Well, no, it would be 5. 5 divided by x minus 2. There we go. Making a mistake on it. Okay, now if you notice right here, we're going to be square rooting an x squared. Okay, but when we square root an x squared, guys, that's going to equal the absolute value of x. Okay, so you have to be very careful to think about this. Now, since x is approaching infinity, I think this is going to stay positive. So we can go ahead and write out x times the square root of 3 plus 6 divided by x squared divided by x times 5 over x minus 2. Okay, and that way, when you think about the nature of it and just how it works and everything, you have to be very careful about this. Okay, because when you're plugging in, when you're figuring out what limit you're approaching, when you're working with absolute values, you have to go and am I getting a positive value or am I getting a negative value? And that's what you want to think about as we go. Okay, so the x's, these cancel out. Okay, and then I just plug in my infinity because those two turn into 0, so it becomes the square root of 3 plus 0 divided by 0 minus 2, which turns into, well, that's just going to turn into this. Let me move over the cursor, and that should be equals the negative square root of 3 divided by 2. Okay, and that's the number we're approaching with this limit. Okay, but you have to be careful when you're doing square root of an x squared or any positive x with a, any even exponent with a variable when you're doing the square root of it, because you have to think about the both positive and negative venture of it. You have to think about what is x actually approaching. If it's approaching negative infinity, we would have a negative x in here. Okay, and you would have seen where it would have gone. Okay. All right, but that's it for limits approaching infinity. I hope you guys... Oh, and also, if you're approaching a limit of infinity, usually the limit is the horizontal asymptote. So that's a huge thing to know, too, as to where we're going, okay? You guys have a wonderful day, and I'll talk to you later. Bye.